Hello, my name is James Wall. I am a pediatric surgeon at Stanford University, and I've been invited by the EarCAD student group to give you a talk today about a business development story. My background was originally as an engineer. In the U.S., we train a full 4-year college degree before we go on to medicine, so I had the opportunity to do engineering. I then went on to become a pediatric surgeon, but have gone back to some engineering roots and have mixed the two specialties in order to work on some medical device development projects. The one I'm going to tell you about today is a company called Insight Medical Technologies. And this is a company that was formed out of my time at a group called the Biodesign Group at Stanford, which puts together young engineers, physicians, and people with business experience to create new ideas in the field of medicine. This idea came from an observation we had when watching an anesthesiologist try and place an epidural catheter. And normally the anesthesiologist, when they try to place an epidural, they'll feel along a person's back and they will blindly take a needle and try and insert it to just the right spot. And they're trying to get to a spot that is literally less than a millimeter from the dura, which is, of course, the outer protecting part of the spine. And there can certainly be complications. Oftentimes the procedure goes just fine, but we observed many people struggling with two main issues. One was they struggled with the ability to control the entry into the space. They have to push really, really hard to get the needle through a dense ligament just before it enters the space. And secondly, they had difficulty trying to find the correct angle because there's many bones of the spinal vertebral column that can get in the way. So on observing this problem, you can see here in close-up what the anesthesiologist does is tries to get the needle into what is the ligamentum flavum. They have to do that, again, through the back. They push on the needle using force to get through the ligament. And then as soon as they get into this epidural space, just before they hit the dura, they try and stop. I mentioned there's complications. We see dural puncture on the left as probably the most important complication. That happens between 0.5 and 2% of the time. And that's a problem because you get a leak of CSF and you can have an incredibly difficult to treat headache, which may even require further interventions. You can have epidural vein punctures, happens about 2 to 10% of the time, in which you can catheterize the epidural vein and deliver systemic local anesthetic, which is toxic. And you can have catheter malposition where the tui just slips out of place. So what the EarCAD student group asked me to talk about was the business development. We saw this problem, but how did we come about solving it and then turning it into a company that now has a product on the market? So the first sort of step that I'll talk about is really the idea, and this is the cheap part. You have the idea, which I'll show you in just a second, and the things you can do around an idea for very little money are establish a provisional patent, which can be done both in the US and Europe for a very small amount of money. You can do cheap proof of concept, meaning just prototype with whatever you have. You can do a market assessment, which just requires some reading, and you can have your idea evaluated by experts, just talking to people in the field. So for us, we developed this idea where instead of using a sharp, blindly placed needle, we'd use a guided, threaded device. It's very simple, but it works, and we essentially said, instead of trying to drive what's like a nail with a hammer, why don't we use a screw that has a blunt tip and that can protect the dura and the epidural veins? And this was one of our original drawings that you see here, and the ultimate device that we've built is not that much different. So this was the idea. We would deliver the screw through a little introducer needle. We would screw through the ligamentum flavum. It wouldn't require any forward force to get the needle into the space. And with a blunt tip, we would be able to protect the dura and inject fluid and deliver a catheter. So step one, as I talked about, was a cheap proof of concept. And what we did, we went down to the local hardware store, Ace Hardware in Palo Alto, and we bought a couple of screws. We went to the local butcher, and we bought a pig spine, I distinctly remember, for $15. That's like €8. And there's your first prototype and your first proof of concept in an animal model. And the whole thing cost about $20. Here again, you can just see the cutout, and you see us taking a screw that is spot welded onto a piece of plastic, I don't even remember, and just seeing, would it hold in the ligament and would it advance itself? And it did. And from that point on, we said, we're onto something. The idea works. Let's go forward. So the next step in business development is really, you got to get a little bit of money behind it. So what we applied for was what's called an NCAA grant that's available in the U.S., but there's other similar grants. It's a small innovation grant. It was worth about $25,000. And that was within the university, within Stanford University. We were able to do a prototype of the device. We were able to do a little bit of cadaveric testing and prove further to ourselves and set ourselves up to prove to investors that the general concept that we're working on was a valid one. So you'll see with this, we built probably 20 prototypes. You have everything here from a piece of metal pipe. You have on the right some crazy ideas using plastic, alternate catheter deliveries. We had an automatic thing. You can see the screw handle there. We were using a drill to drive it in automatically. This is really a fun, creative time in building a medical device. And we had all kinds of models that you can see in the middle where we were trying to replicate what the device would do in a human so that we could test it very cheaply on the benchtop. And I think this is probably the most fun step in the process. You have the idea, you want to see if it works, and you can just be as creative as you can. And again, not a huge amount of money. We had to pay for some of these materials, but not a huge amount of money. So the next step in the process, once we had proved that to ourselves and we had burned through our $25,000, was to do more extensive animal testing. And we were able to get a larger government grant, which is called a Small Business Innovation Research Grant. That starts out at about $100,000, but as you hit the milestones of the grant, you can get up to almost $1 million in grant funding. Again, that's within the U.S., but these grants and funding sources exist elsewhere. And this allowed us to do extensive animal testing to turn a device from a benchtop prototype into something that we would be comfortable putting into humans. I won't talk a lot about that process, but it is extensive. We're talking about push-pull testing, strain testing, making sure that the device will not break, and making sure that we have something that's really up to FDA or European regulatory standards. So we did that, and we got to an FDA submission. Fortunately, the FDA said, absolutely not. And fair enough. We were early. With that money, we had moved the device out of the university and had started a company, but we really didn't have the expertise within the company in terms of manufacturing, sterilization. So we had to go to the next level. I will show you a couple of the results of the animal testing before we talk about the next level. This is a fluoroscopy image of what we were able to do, again, just with funding within the university. You can see us with the needle here. It's rotating into the space, and then you'll see contrast as it injects into the epidural space. And there we go. And that's a pretty compelling image, and one thing you have to know about raising the next round of money, which we're going to talk about in business development, which is talking to investors, is that an image really is worth 1,000 words, and this was sort of one compelling animal study that showed that we had a system, you can see that it works, you can see that you can enter the epidural space, and that was important to do with a little bit of grant money in order to go to the next level.